Try to model myself tripolar complete systems. So I'm trying to model myself literally in framework of OBNXS. So what it really? So I have a diagram here. Yeah, I have a diagram here. So basically, this is a graph I made today, but it basically covered with through. Now the next one I will show you later because it's a video. But I'm not naked, am I? Yeah, I am not naked, so just my top. So it's gonna go in the system, but just look up. So the good to have this model is system. I'm doing this video here. Yeah. So what's the difference? So we don't have a simple. So OBS is opening up. Come on. So recording. Yes. It's not going to record me. Record it till I close it. Yeah. Yeah. So okay. So basically, this is drift from here. Good morning. This is basically my tripolar self. I'm trying to model myself. So basically, the tripolar self is literally what I'm going to model. Once again, guys, let me get to my GitHub and show you what I mean. Yeah, drift theorem, github.com, github.com/mk2 drift theorem. Yeah, so basically, here's the new main file here. Yeah, so drift theorem is a self-referential vision system. Uh, it's a self-referential system, but I'm just model the tripolar architecture. So this is just a purpose to be part of the system. So the computers were doing the heartfelt systems. I'm really beginning the video of the system, knowing what it does, knowing what it is, knowing what it's going to do. Well, the drift theorem, let me just show you the video, Namdi. So this video here I made, once again, guys. Yeah, this video here. So this video here, basically, it does work, but this is very important, guys. You understand that it's got basically the Insigi firmware. So because listen, this is so the Insigi firmware is literally a cybernetic firmware that gives you food, water, and shelter based on the tracking telemetry of the data. But the data is going to work from the real. So this one was digital or not, it makes sense of the data. I'm called cybernetics because it knows to act on the data based on probing. Probing, question is a probe. But something ask questions literally, by getting information based on what it is doing. Uh, uh, yes. So this drift system, this is like a static system. So I'm moving. So the system knows where it's in process. It's not AI. It's without AI system. It's not AI system. But this is the flow system. A graph, weighted G, cost, line, super, Drew, but it's gonna be tripod separate colors, But this is the film, so it's not really good about color coded, but I'm showing you something here. So if I go to the GitHub page, with zero, GitHub.com OBXs of Moscow, B for Bravo, Alpha Indigo, F Noble, F F for X-ray, E for Color, server MQ2 /drift underscore zero, we get the drift theorem. So let's read this aloud and understand the So you know, so basically, so let me just read what I'm saying. So basically, you need to switch on other camera. So, Namdi, what are you doing? So I'm trying to model this systematically. I'm saying I'm complete. I'm not perfect. So maybe I am perfect. I'm complete. As long as I'm not broken, not broken, I'm claiming I'm perfect. You know, I'm complete. So it doesn't damage part of my body. Because since there's no break, I have to be complete first. It's no break. So this is the model here again. So the model will be this kind of see basically this is an axis of symmetry. This is one axis of symmetry. And you're gonna have two axes. You're gonna have one axis of symmetry in the center. You're gonna have another one crossing up diagonally. So you're gonna have two axes. Then you're gonna have two axes of symmetry. Let me just try and draw that now. One second, guys. Let me try and draw that now. Oh god, it falls. I didn't. Two axes of symmetry again. Crossing the line. Uh, one more orthogonal angle of symmetry. Yeah. So you're gonna have three axis symmetry this node. So this is only two so far I've drawn two lines, but it's only three depth. So you're gonna have to split this up. This is a bipolar axis symmetry. So you see these lines here, they've crossed twice. So it's what I call the mirror symmetry lines, they cross twice. So they cross each other at a point. But that point is a 2D space. So it solves the density problem. So the density problem is a heat density. And this is why I eliminated it's a density elimination. So these lines are called mirrors. Axes are called mirrors. So the vectors can project here and opposite side here, another side, and the goal is to have them project in three dimensions in R3 space. So basically, when this vector components are 5 in 2D can be mapped onto a 3D surface without having some kind of without breaking the 3D laws, breaking its 3D laws, because it behaves like a fluid vector. It's a vector. It's called an auxiliary vector, but it's just but it's basically auxiliary vector, which you measuring something else. But the system has to work the curve. Doesn't matter where the system is, the surface is not gonna start glitching out of reality basically because the vector holds the space of the basically the 3D vector can obey the rules of the 3D system without without the beauty of the system. So that's what I'm saying. So I put two there for now, but I'm tripolar, so I need that. Basically, the term is gonna come into it. It's gonna project. So see these two vectors here, one and two. One, basically this vector here, and this one here, this one's a mirror of this one. And this one, basically, if you take an angle, this one will be pointing up. So this one will be sticking out like this pen here, because it'll be sticking out into the 3D reality. But it'll be projected into 3D. But you can do that as a two. So you already have the system. So basically, you're gonna project inside here. Inside here, you're gonna do this and come out like this number. That's go. Basically, so as you come out this line, basically, let me do some. So for example, you get u equals 5 5, and you get an axis of symmetry. Basically, this is called asymmetric. Drift theorem asymmetric symmetry. So basically, you get three axes of symmetry in this model, and you're gonna have a circle. So imagine a circle around the axis of symmetry, and they divide the circle in three. You have to integrate all the six. So see, you have the three system project into kind of a block sphere notation. But the block sphere so like because they have it can be sequence systems too. So basically you're gonna have a block sphere. You have a circle. You divide it into three. And those three axes are going to project X, Y, and Z. And then saying the blocks matter. So you have three axis symmetry in a system that divides them by dimensions of x, y, and z. So the dimensions can be integrated over the space of it. So basically, that's what it is. So, for example, you get the vector u five two in 2D, and you have the point of symmetry, the all using -2 -4. Now, the point A is basically just one dense point, and that dense point maps into a system of linear equations. They can define rotation, reflection, rotate or basically reflection of the symmetry. But the because you're computing reflection, you have to compute rotation, and because you're computing rotation, basically it becomes this strange system. Basically, you can because the symmetry is there. You need reflection. You can define rotation. You can define enlargement. You can define enlargement, which is enlargement, which makes things bigger. You can define rotation, which is basically something rotating, and you something moving around in a circle, in like a using circle tower. And these laws are being distant. So this asymmetry symmetry is what I'm tripolar modern or tripolarness as. My tits. Oh my days, guys. But it goes to have them there. Okay, guys, thank you for watching the video. I'll try to upload it here. But it should not work. Okay, thank you guys for watching. Basically, I just showed you my tits. I mean, not my tits, my chest. But thank you for watching the video. So basically, after you talking here, basically, I just showed my chest. So I'm gonna put all the recording on YouTube instead. So I'm gonna put the video here, but I will not bother the video because it's my chest. I just woke up in the morning, and I'm not stressed about it. I'm just like so the goals to have system have no symmetry of the cases modeling at. For example, you have the U 5 4 A minus 2 4 V minus 5 minus 5, which is opposite symmetry of the system. But the vector component of U is mapped to V, and V has four conjugate models. So U has V W minus 5 5 and x, which is a little vector component, UVW x, which is 5 minus 5. So these vector components are regions of symmetry that can be used as channels, channel space, but they only work in symmetry, though the symmetric law. So the symmetric law, what I'm calling symmetry can allow systems to be distant and work together, because they doesn't want to just a norm, they can work together like a swarm drone or something. But the good is we have the system neurodivergent like me, because Uche is one pole of mine, I'm tripolar, one person in me. Eze is one person, one of us can use to talk or go somewhere and do anything I want to do. Eze means king or leader, and Obi means heart or soul. It goes to continue work, but continue doing this properly. So, I'm gonna put the video down. But I have to see how the system gonna work because I cannot put that video on the internet. Doesn't matter the point in space. The system has to respect the fragility of yeah. So basically, I'm just watching the video trying to cut it out. I don't know what happened. Okay, so what points are mine? So 510 open with media player. Yeah, so you go to have the system edit with clipchamp. uh, Edible clip so 5 times I destroyed all of them. So you're going to have the video like the action symmetry gives you destroying point. So doesn't matter if the action symmetry shift, it becomes the system of shifting. So the is the action symmetry of shift, the drift and shift, but not the actual point people in space and time. Because if the actions are isotropic, isomorphic and geometric, you will not have that problem of drifting. So what drifts here in this model is the system. So let me just play this video. Let me just play this transcript and you guys can listen to it. But 3, 2, 1. I think it's you now. I just can't see. So basically, what was that? So so it started from CT equals the position of the vector comma in 3D space. Now, PT is the position of vector observed space objective, and VT is relative observer vector. So the formula is VT, where T is the time, equals PT minus CT, where P is the position of the observed vector and C is the camera position on 3D space. So the asymmetric system is isomorphic and isotropic because it's topological. So it's really a preserved isomorphism of your identity, me, myself, and I in 3D, but they have just one axis of symmetry. The sheer one they can move around because people are moving around in their own reality. You understand? So the beauty of the system is the isomorphic nature of the symmetry places, but it's a trident symmetry pattern. So let me continue playing my video interpretation. So yeah, so the interpretation. So you're gonna have the drift as observed state of defined as a time curvature. So the time curvature will be the moving away where the radius is more than zero. Now we approaching these less than zero, and the drift radius and distance on chain equals to zero because it's basically based on the kind of polar the math I did before. But it's a lateral displacement system. It's a unilateral system, but it's a lateral displacement if it's just angular. So basically, if it starts to move an angle, you can turn that to because angular drift. Because drift theorem just means that things that actually have a tendency to move away from you. So let's continue playing this video. So notice what numbness. That's that's concept. So the system has to resolve 2/3 plus 1/3 of the system. Basically, it's the weighted average for geometry. You can do 2/3 of C, sorry, it's 1/3 P, for the precision points, of course, but that's the weighted average system. So, let me stop the teacher now. But let's read this thing out. Okay, let's read this thing out. Let's read this thing out. Basically, let's read here. Start from here. Let me see. Can I read this? No reading. Can I read aloud? No reading. Okay. I think I have to refresh it. I want the system to read it, not me. Read aloud. You don't want to give me how song. Because they depend, because lottery depend on each other. Yeah, but this basically, I just think it's the actual symmetry model, but it should just work as the actual symmetry model. So it should just be working for the actual symmetry here. And the actual symmetry should be able to do something with it, based on how it's system. So the goal is to have this asymmetry model pass over the system. Basically, got symmetry asymmetrically because there's no symmetry via dense point, which is obviously the mirror, and this mirror gives you three interpretation of the system based on the kind of angle which is basically this model is better. It's better over this disjoint, and it's really disjoint because it's symmetry. There's a mirror there, so you get one mirror, one axis of symmetry on the x on the x coordinate, one across the y x-axis, across the line, wherever the space and time is, you're gonna have one axis of symmetry that's projected in the z coordinate. So you have three axis of symmetry in this model, and that's for all the sets of real spaces, all the real numbers, all the space of real spaces. The real spaces will be the real numbers, such as vector, imaginary, and vector. So you're gonna have x, y, z components. Gonna be on a plane, and this angle plane is gonna be if you move the right hand row, you can call it left hand row because it's it's basically symmetry. Basically, if you remove the right hand row, x, y, z, you will get the projection point of the cross product. But the cross product is and the cross product will work for the system of non system. So any point, any kind of vector that lies in this auxiliary vector, auxiliary space, auxiliary rule space, will be able to project itself in any direction, the opposite direction, opposite conjugate system, because it takes the drift account into model. So it doesn't matter where the AI moves or not. It knows how. It has three frames of reference to basically so when the symbolic system moves, it has three frames of reference to continue stuff based on the rule spaces of R1, R2, and R3, which are the rule spaces of the element of the component vectors that are used. Doesn't matter if it's a one component in the vector, two components in the which is called scalar, or two components that in the vector is active. They still have to mirror that in and they will and give it the meaning based on that conjugate model, which is basically the row column vector. Plus or minus, or when you switch the signs, basically. That's the beauty of the system. Thank you guys for listening to this audio. Thank you.